the other hand, the splanchnic mesoderm, when combined to the lower endoderm, will give rise to the splanchnoplure. Okay. Let's take a look at the positions of these layers relative to one another. If we are to cut an amphibian embryo, we get a cross-section specimen or cross-section micrograph. We can see how the mesodermal subdivisions are associated positionally with each other. So we're seeing the notochord in the middle. On the sides we have somites, so two or one somite on each side. So that's one pair of somite. It's paraxial mesoderm. Okay. The structure beside somites here. So probably we can somehow say this structure here give rise to intermediate mesoderm, while this area here, so on, give rise to lateral plate mesoderm. That when this lateral mesoderm splits as splanchnic and somatic, right, they will produce the coelomic cavity, and the layers will fuse with ectoderm and endodermal layers, giving rise to splanchnoplure and somatoplure. On the other hand, in flat embryos like discoidal avian embryos, the same position can be appreciated, though we don't expect a spherical configuration. Okay, so seeing here after morphogenetic movements, neural plate formation, right? Mesoderm between the ectoderm and the endoderm, you're seeing the somites and the sides of the notochord. Your intermediate mesoderm directly beside the somites, so this one, intermediate mesoderm. Okay, and your lateral plate mesoderm, that on this diagram, in these pictures, we're seeing that the lateral plate mesoderm have in the process of splitting, okay, forming the coelomic cavity. Let's run down the divisions of the mesoderm and the derivatives, the adult derivatives that are originating from them or that are actually attributed to them. Okay. A paraxial mesoderm again gives rise to somatic areas or somatic pairs, head mesenchyme, okay, also be derived from it. So where somatic pairs described as possessing three components. We have the sclerotome and the dermamyotome, which divides into myotome and dermatome. Sclerotome gives rise to cartilage tissue, similar structures, associated structures. Myotome gives rise to skeletal muscle, and dermatome gives rise to dermal structures. Okay, paraxial mesoderm, somites, and head mesenchyme. Our chorda mesoderm, primary inductor. We remember in the beginning of this lecture we mentioned so much about chorda mesodermal tissue becoming notochord, becoming the primary inductor for primary neurulation to take place. On the other hand, intermediate mesoderm, just after somites, can be seen on both sides also, giving rise to excretory organs like kidneys and gonadal tissue. And lastly, lateral plate mesoderm divides into splanchnic, somatic, and extraembryonic parts. Splanchnic parts contributing to circulatory system organs, somatic part giving rise or contributing to body cavity, and of course we have extraembryonic investments that are derived from the lateral plate mesoderm as well. Let's continue our discussion with the development of somites and somitomeres. Okay, somitomeres and somites, you might guess that they are very much associated with one another. So let's discuss the differences and the process that they follow to actually develop. So our production